My name is Andrei Balint, and now we shall be talking about essential tools in Red Hat Linux. But these are essential for all Linux distribution. You need to master them and get a good overview of them in order to be able to handle either simple or more complex system administration tasks. So let's get to it actually. So first we have the command line interface. So the command line interface processes commands to a computer program in the forms of lines of text. The program which handles the interface is also known as the command line interpreter or command line processor. Operating systems implement, usually, the command line interface in a shell for interactive access to operating system functions or services. So, to put it in blunt terms, you type in commands and it does what it does in a very fast way. Let's go through some basic Linux commands, and I will be using my Red Hat Enterprise virtual machine in order to best show you this. So, I'll just clear my screen. So we have ls. ls lists files in the current directory. At this point, what is my current directory? I can find this out by using the pwd command. This determines where I am. As you can see, I am in the /home/Andrei Linux file system hierarchy. So let's do an ls. So as you can see, this is what I can see in this particular directory. Desktop documents, downloads, music, pictures, public, templates, videos. All of them are highlighted in blue as they are folders. If I would like to read or show the contents of a specific file, I can do the cat file type command. Cat actually shows the contents of a specific file. So I am using the passvd file in order to best illustrate this. And these are the contents of the passvd file. If I were to be focusing on just the, let's say, last 10 lines of a specific file, I can use the tail command. I'll again be using the passvd type file to best illustrate this. And these are the last 10 lines of the passvd file. Another interesting command to note is the echo command. The echo command just prints what I say to it that it should print. In this particular case, I wrote test. So you can see in my output, it has printed test on my terminal. Let's clear this a bit. I can also tell it to print strings. So instead of test, let's say this is a test. And it has successfully printed this. Another command which best illustrates who I am as a user at this point in time is who am I. This will print, the output of this command will be the user which is currently logged in who has run the command. In this particular situation, it is the root user. In order to create files, we use the touch command. Touch command and the file name will create a file in this with that specific name, such as touch test file. We can see that using ls that we have a test file in our listing. It has been successfully created. And we can use word count to see the number of lines, words, and characters of that file. 000 as it is empty. Let's modify it a bit. I am a test file. Hello. As you can see, 23 characters, 6 words, 2 lines of text. So these are basic Linux commands, and they are one of the most, let's say, used types of commands that you can find in Linux, among others, but these are very used. So let's clear the desktop and move on to the next slide. So bash. So what is bash? Bash is actually the command processor which runs in a text-based window where users type commands that cause different actions. Bash is the terminal I was writing commands into a few minutes/seconds ago. Bash can also execute commands from script files or a shell script. Think about a shell script as a set of steps that you need to do, kind of like a cooking recipe. You give Bash the recipe and it follows that specific recipe. Like all Unix shells, it supports various functions, such as globbing, piping, command substitution. So I will go through the most, let's say, basic and the most useful of them. So it has the tab function. What does the tab function actually do? It auto-completes. If I were to write HIS, Then I can use tab to autocomplete the command. As there is only one command which starts with HIS, well, it will autocomplete history. But if I were to just write H, it would show me all of the possible commands which could start with H. Or if I were to, let's say, want to change directories, and I'm not sure on the hierarchy, so pressing list could actually be annoying. CD/home/Andre, and Andre is the only folder there. But maybe I'm here. Double tab will show me the possibilities of where I can actually change directory to. So it also does show possibilities as well as autocomplete function. I was talking about the history command. What does the history command do? Well, another function of the bash is the fact that it has a history of commands, which can be viewed by either pressing the up arrow, as in this particular case, or the down arrow to go either up in the list or down in the list. Or in order to check the list of commands which was given, I can just write the history command. And it will show me all of the commands which were written in this particular terminal. One of the functions which we will be going a bit more in depth in the following slides is piping. Piping is the concept of redirecting the output to serve as the input of another command. So I can redirect the output of a specific command to act as the input for another command. And I can, using the bash functions, I can also do command substitution or also an alias. What is an alias? Well, an alias is the concept of replacing a command with a placeholder. So, and I can program these to better customize my environment. So I'll clear. And let's think about it in this way. Alias, W equals word. Let's say, who am I? What did I tell the bash? Well, I told the bash, whenever you see W, W is actually who am I. So if I were to run W, as you can see, it has actually run the command also known as who am I. So this makes it easier to customize your bash environment and makes working in Linux a bit easier. So when it comes to Linux, you can also redirect output, input, or standard error streams. There are three actual main streams that we should think about. So there's the std in, std out, and standard error. These three streams also have a numerical value associated with them. Standard input is 0. By default, the standard input is the keyboard. Standard output is 1, and by default, the standard output device is actually the display, and the standard error is 2, and the standard error output device is also the display. Linux does include redirection commands for each stream. These commands can write output to a file. If a non-existent file is targeted, then a new file is created for writing. If I just use one character, so lower or higher than, then I am actually overwriting the destination. That means that I am overwriting whatever was in place in that specific file if there was something in place. If I'm using two characters, then I am appending. So I'm adding to what was there present at that point in time. And let's do a test on these ones. So I have my terminal here. I'll just clear. And let's say that I am using touch, or actually I'll be using echo to best illustrate this. This is a redirect. And I am redirecting the output, as you can see, to a file called redirect. If we can look, we can see the file has been created, and I can read the file and see it does contain the sentence which I have redirected. If I were to do this command again, I would obtain the same thing. Why? Because I have overwritten. So whatever was in place no longer is in place at that point. I have just overwritten. Even if I do modify the command, such as adding the new output will just be there. The old output will be overwritten. If I use double characters, I will append. That means that now I have added to the existing file. I have not overwritten it. If I do want to redirect the error, let's create an error. Cat error. Well, cat error is an error Why? Because there is no, well, error file. So let's try and redirect the error message to the error file. The error file has been successfully created. Let's see if it does contain something. Okay. So at this point, it does not contain anything because I just created the error file. So that's why. Let's say error 2, and this would work. No such file or directory. So the directory does not exist, the file error2 does not exist, and the error has been redirected to the error text file. Why didn't it work the first time? It's because I created the file and afterwards there was no error at that point in time, as the first thing that Linux checked was if does that file exist, and because it did not exist, it created it and then it ran the cat command. And now let's go to pipes or piping. So piping is the idea of redirecting a specific output stream to serve as the input stream for another command. And this is useful because I can also use filters. Filters are commands that alter piped redirection and output. Filters also are most of the time standard Linux commands, which can be used independently without any pipes in place, such as find, which returns files with file names that match the argument which was passed to the find command. grep, which returns text that matches the string pattern passed to grep. T, which redirects standard input to both standard output and one or more files. And word count, which counts characters, lines, and words as we've seen. If I redirect anything to /dev/null, it's kind of like discarding it. That is a special file that is used to trash any data which is sent to it. So redirection to that particular spot in the Linux file system will just cause it to be trashed. So let's do a bit of piping. Piping is done with this particular character, which is the vertical line. So let's go. I will do cat/etc/passvd. As you can see, it has written the entire passvd file, and I can see that I have a user called Andrei. The passvd file gives us information about users. So let's redirect this to the grep command to filter it. And the grep command, I'll tell the grep command to filter and find me the line which contains Andrei on it. And as we can see, it has successfully done that. Andrei is highlighted in red and only the Andrei line was shown. Let's do this a bit more clearly. I'll just clear the terminal. And only the Andrei line was shown. So that is why redirection is useful and filters are very useful in this regard. So to best understand Linux, we also have to understand a bit the file system on Linux, how it works. And in this particular sense, we are doing a bit of a short overview. So the file system in Linux functions on the basis of an hierarchy. First, we have the root directory, which is actually symbolized by the slash. The slash is the root directory, and from the slash, all the other directories are theoretically accessed. And depending on the type of directory, each type of directory contains a set of information specific to it. The /bin directory is a directory which contains binaries. That is where some of the applications and programs are present. The /boot directory contains all the files required for booting the Linux system. The /dev directory contains device files, such as hard drives. The /etc or etc directory contains configuration files most of the time. The /home directory contains the user's personal directories and files. The /lib directory contains libraries. /media is for portable media or external storage, and this is where it will be mounted when you plug it in and when you try to access the data on it. /opt is where applications which you create end up most of the time. /proc is where you have information about your device, such as CPUs or kernel version. /tmp is for temporary files. /usr is for random things. And /var is for data which changes frequently, such as log files. So now that we have a basic idea on the Linux hierarchy, and what is stored where, how do we actually go through it? How do we move through the hierarchy? This is done through the cd type command or change directory, which takes you to a certain directory. So let's use it a bit. Let's clear. At this point, I will cd change directory to the /home/Andrei directory. I have successfully done that. I can see I am in /home/Andrei. If I just use change directory without any type of additional arguments, it will take me to the home directory of the user which I am using. At this point, I am using the root user or the administrative user. So by doing this, I am now in the administrative root directory. As you can see, I am in /root. If I do use cd space ... it will take me one level up in the Linux file system hierarchy. I am no longer in /root. I am in just the root file system at this point. If I want, I can also use relative paths. So changing directories based on my actual position within the file system. cd, tab to see what is available to me, and I can go in home. Then I can go in Andrei. Then I can go in videos, etc. If I would like a good listing and a bit of transparency and visibility on what are the contents of a specific directory, I can use the tree command. The tree command will give me a good visual overview of how the contents of a specific directory are actually present. /home, let's say. So in /home, there is a directory called Andrei, which contains these directories and these files. This is what the tree command does. It's a very nice visual representation of a specific directory. And let's clear this and move on. Okay, now that we have been talking about the Linux file system and about the bash as well as the command line interpreter, we shall be talking about the man page. So man stands for actual manual. Manual is a form of software documentation which is found in Unix and Unix-like systems. It's one of the best tools that you can use in order to get detailed information on Linux usage commands. In order to read the man page of a specific command, you need to do something like this: man and then specify the command which you want to document on, such as ls. And this gives us the name of the command, how it is being used, and what the arguments or options of the command actually do and how to use them. If I would like to go to the end of the manual for this specific command, uppercase G or shift G will take me to the end. G simple or lowercase g will take me to the beginning. Why is this useful? For some complicated commands, such as, let's say, se manage f context, the bottom of the man page will contain examples. So that is why this is quite useful. I will find usage examples at the bottom of the man page. If I would like to search for something within the manual of a specific command, I can use / and then specify the search term, such as, let's say I want to search for restore. And as you can see, this has showed me all of the lines which contain restore. And I can go through the lines by using the N key through the results. If I want to quit the man page, I can just type Q and I will automatically quit the man page. If I want to search for a specific command, such as, I don't know the command and how can I change a user's password? I forgot how the command is actually going for. I can type man -k and specify what to search for, such as password, let's say. This will give me an overview of list of all of the commands which contain the keyword password. And based on this, I can research and find out the command which I am actually looking for. In this particular situation, I would be looking for passvd, the password file. Let's clear. Man functions on the basis of a database. And that means that in order to refresh that database, we need the command and we need to run what is called mandb. And this will refresh the database of the manual. This is especially useful when installing new packets just to be sure that the manual pages have also been updated and are present inside the manual of Linux. In my particular case, there was nothing to add as the database was already refreshed. So let's clear and move on to our new topic, which is text editing. So text editing is quite important in any type of Unix-based system, including Linux and Red Hat Linux. Why? Because they use a lot of configuration files and you'll need to edit them in order to, let's say, customize or troubleshoot or do whatever with your Linux distribution. Vim is the upgraded version of VI, which is the text editor used in the command line interface. Unlike modern text editors, VI and Vim do not use menus or icons, but they do function on modes. You have multiple modes, but I will go into the three most important modes associated. In order to enter a specific document with VI or Vim, you just write Vim and you go for the document. I have nothing here, so let's go into test file. There are three modes which I would like to present. First is the insert mode. In the insert mode, you can insert text in a document. In order to access the insert mode, you type I. The interface will quickly change to insert and you can add whatever you would like. If you want to exit the mode, you just click escape or press escape. Another type of very useful mode is the visual mode. You enter the visual mode by pressing V, and the interface will show you that you are now in visual mode. And in this one, you can visually select text, as you can see. Escape again in order to exit visual mode. What can we do in Vim? Well, in order to master Vim, we need to be able to use the reference keys or the reference commands. So in order to save a specific document, we need to use W. As you can see, test file has been written. If I were to exit and I exit using Q, if I were to enter again test file, I will see that the changes are in place as they have been written. If I want to save and exit, WQ. If I want to copy something, I will need to use the Y key. This stands for yank. So let's assume I am going now into visual mode. I press Y. I have yanked this part and I want to paste it. Well, the key for pasting is P and it stands for put, not paste actually. And I have pasted it. If I want to copy an entire line, I will click Y 2 times or press Y 2 times. And I can then paste using put. And as you can see, I can copy an entire line in this particular situation. If I want to delete or cut a line, I use D. DD, DD, DD. If I want to undo, I use U in the command mode. And as you can see, I have undone specific changes which have been brought to the document by me. If I want to search for something, it has the same syntax, slash to search for specific things such as, let's say, test, and it highlights the results, and I can go through the results by using the N key, as you can see. And this type of search goes from top to bottom. If I want to search from bottom to top, I would use question mark test, and now I go from bottom to top. So let's exit and let's move on. And let's move on to what is called globbing. So what is globbing? Globbings are patterns I can specify in order to identify files or identify specific patterns within files. There is a reference in the manual of Linux. I can write man glob and it will give me information on what globbing is. Glob, find path names matching a pattern. And how can I use these wildcards? Well, these are the essential wildcards which I can use. Star stands for anything. So let's assume the following. I am here in Andrei. Let's say I want to list everything which starts with P and continues with whatever, such as pictures and public, as you can see. So wildcard, this particular, let's say star, stands for anything, wildcard. Let's say I want to actually search for a file or a folder which contains P, then an I or a D, and then anything else. But there is nothing to show in this particular situation. Let's say pictures and public. So it shows me pictures and public in this particular situation. When it comes to question mark serves as let's say a substitute for any one character. So if I were to look for things which I have approximately 6 characters, like public, ls, as we can see, it has found public and videos as results. So anything which has 6 characters. And these types of globbing commands can be used in any type of situation, be it when working in Bash or when using VI or browsing the man page. So this would be it in associated with the first part of essential tools in Linux. In the second part, we shall be going into file management, and as the pun says, kind of useful in any system, because any system has a file system. And we shall be learning about making directories, making files, removing directories, removing files, etc. So what have we learned in this module? Basic Linux commands. What are the benefits of Bash and what type of functions can it actually do, such as autocomplete, have a history, do redirection and piping, aliases, and run scripts, which we shall be covering in a further course. How can we redirect output, input, and standard error to specific files? How can we create pipelines to give the output of a command and serve it as the input of another command? What are the basics of the Linux file system and what each directory in the Linux file system holds, theoretically? How can we navigate this particular file system? And how can we browse the manual pages? And how can we use the particular VI or Vim in order to edit text? Thank you very much, and I look forward to joining you in the next module when we shall be talking about file management.